Welcome to Chapter 8, Section 2, called Parallelograms. This is for Integrated Math 2, or IM2. So a couple of things that you'll see on your screen here before we get started. The first thing you should see as a student is a due date. I don't see that on my teacher preview, but you see it on your student side. The second thing is the number of attempts. Remember, you will always have unlimited attempts on homework, tests, and quizzes. Number of questions just lets you know how many are on this particular assignment. Grading policy is best score, so whichever attempt is the best one's one to keep. And partial credit is enabled, so if you answer one of 4 questions correctly, you get credit for 1 question, or however many you answer correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click Start, down in the bottom right corner, you will see a Submit Assignment button. I don't see it on my teacher preview here, but you will see it on your student side. This is how you finish an assignment, is by clicking this button. So as soon as I want to leave this assignment, whether or not I finished all of these questions, I don't want to close this tab by clicking the X. I don't want to close my computer. I want to click Submit Assignment so that the system doesn't lock me out of all of my other assignments and resources. That's what it means by you can't work on anything else. It's going to lock everything. It's going to assume you want to leave this attempt open. Remember, you have unlimited attempts. There's no reason to leave it open. It will save your place, so whatever you have answered correctly already, it will know that and it will save your place. And it will, stop it from locking you out. The other big thing that it does when you click Submit Assignment is it affects the gradebook. So your teacher can actually see what you've been working on. Until you click that button, your account's basically frozen in that place. We don't get to see anything that you've been doing. So just good habit, always click that button. On the side here, we always have explanation, example, and message center. So explanation tells you you're going to lose your question attempt because it's literally going to explain this question to us and give us the answers. So it's not going to give you the answers and let you come type them in. Example will do something very similar to explanation, except it's going to give us a little bit more of a general example. So something very similar to what we're looking at, but not exactly the same problem. These 5 properties are very important for this type of problem. So when we have a parallelogram, oops, I hope if I actually have my pen on. So when we have a parallelogram, there's 5 properties that we need to take into account. Number 1, opposite sides are congruent. So left to right, top to bottom, and I have 1 marked to 1, 2 to 2. Opposite angles are also congruent. So I have to go diagonally to do opposite angles like this. Consecutive angles, so these guys, the sum is 180, or they are supplementary, meaning they add up to 180. And I can do that on either side, or I could go on the bottom as well. So as long as I'm going one right after the other, that's what we call consecutive interior angles. They will add up to 180 degrees. Alternate interior angles formed by a diagonal are congruent. So this is true. We were learning about this in the last section before the semester, last semester ended. If you have 2 parallel lines and a transversal like this, so I have a parallel line and a parallel line. Remember, it's a parallelogram, so that's another basic definition, is that opposite sides are also parallel. So I know I didn't mark it, but here's my parallel mark for the top and the bottom, and then I go 1, 2 for the sides like this. That's the basic definition of a parallelogram, is that opposite sides are parallel. So if I have opposite sides parallel, and then I also have this transversal going through, or if I just connect the diagonal, it doesn't need to go all the way through, like this one stops, then I would have these opposite alternate interior angles being congruent. So there would be 2 on this side, and then I can also go on this other side like this. So remember, alternate means I'm crossing over the transversal and I'm going as far away as I can without leaving the interior of the parallel lines. So with this one, I'd go to the other side and then slide as far away as I can. Should be this one here. And then it also says that the diagonals bisect each other, which means that the diagonals are split into 2 segments that are equal length. So if they bisect each other like this, that means that this is the midpoint for each one. So this length would be the same as this length. It cuts this one in half. Well, it also cuts this one in half. Doesn't mean that they're equal. That's a special parallelogram we'll get into later, but they are congruent. Cut in half for that segment. So there's actually 6 properties here because I also did the parallel sides. So a lot of things to remember when we come to a parallelogram. So as we go through, that's the big thing we want to take away from that one. We can click example again if we want to see another one. We can also message our teacher directly from the screen, and it'll attach a picture so they know where to come help us. All right, so consider the parallelogram ABCD below. We have ABCD. Use the information given in the figure to find angle A, X, so that's length X, or part of a length here anyway, because it's 2X, and then angle ABD. So I'm going to kind of redraw all that. I didn't do the greatest job there, but it's fine. And we have a transversal going through there. B, C, D, A. And let's see. They give us, this guy up here is 30. They also give us this guy over here is 113. And they want to know what A is. Well, if I ignore this line going through, these are opposite angles. And remember, opposite angles are congruent if it's already parallelogram. Well, we know it's a parallelogram. They're telling us it's a parallelogram. For this guy over here, and I just hadn't written this in yet, we have 4 and we have 2x. Remember, opposite sides are also congruent. So if this equals 4x, or this equals 4, this also equals 4. So I could just divide by 2 to solve for that piece. So 4 divided by 2 is 2. So x must be 2. And then the last piece is ABD. I'm going to do this in a different color here so you can see it. So ABD here, because it goes ABD. They want that one there, like that. And remember that we have this 113 down here. And let's see, consecutive angles. So I can fill this in. There's a couple different ways I can do it, because I can look at it from this side, or I could look at it across here. And these two angles, remember the consecutive angles? That's this one here, where they have to add up to 180 degrees. So I know that 113 plus 30 plus whatever this is have to add up to 180 degrees. So I can say, okay, well, I'm using 113 and 30. Add these two together. So I want to know, what am I using? And then if I subtract, that'll tell me what's left over. Like this. So let's see, we get, oh, I have to borrow. Silly me. I was almost going to subtract without borrowing. Crazy, crazy person that I am. So I get 37 degrees. So this has to be 37. So you can see 30 and 37, they're not congruent. Doesn't split this angle in half. That's another one for a special parallelogram that we'll learn about in this chapter. But it's not true for all parallelograms. So they can definitely be different on either side. But now that I know this is 37, this would also be 37. So that was another way that I could have done that. Is that, again, this is a triangle. Triangles have to add up to 180, so I would have gone through the exact same process that I just did here, and then I could have applied alternate interior angles. Or same deal, I could have brought the 113 over here, which I already knew was here. The 30 can drop over here because of alternate interior angles. And then again, I have 113, 30, and question mark. I need to know what is this going to be in order to add up to 180 degrees. So 3 different ways, exactly the same calculation for whichever one you choose, but 3 different ways to kind of look at that and fill that piece in. All right. Let's go ahead and erase this guy. Try not to erase all my properties. Okay. So this is a proof, and we've been working with proofs now for a little while. They can be, a little bit different. It's definitely a different process when you're looking at this. So it says, use the given information to complete the proof of the following theorem. If opposite sides of a quadrilateral are congruent, then it is a parallelogram. So we're proving that it's a parallelogram. We're not given that it's a parallelogram. We're given that opposite sides of a quadrilateral, four-sided figure, are congruent. So this is the converse of what we're normally given. In this case, I know it's a parallelogram, so all these other pieces are true. Well, we can also take all of these pieces, as long as we have a quadrilateral with these pieces, and there's actually a couple others that we can use too, we can prove that it is a parallelogram using certain properties here. So down here it says, By definition, a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Use this definition in your proof. So they're kind of pointing us in the direction that they want us to go. So by definition, we need to show that the opposite sides are parallel. So in this case, they give us that QR is congruent to ST, and I'm going to go ahead and draw this guy over here because that's not the greatest drawing, but the point is not necessarily that it's the greatest drawing in the world. It's just a drawing that you can use to help you mark things so that you don't have to try to remember everything off the top of your head. So I have QR, which is this side here, and that's congruent to ST, which is that, so I have the right and the left side. And then I'm also given that QT is congruent to RS. So that makes sense because it told us if opposite sides of a quadrilateral are congruent. That's what we're starting with. So those were our two givens, and they already put them in our proof for us. The second part is the reflex. So with this one, what we want to do, since they're using reflex, I already kind of know what they're telling me to do, is we have this line here in between, and I know I'm not very good at drawing that guy, but they do share it if we're looking at just the triangles here. And we're going to kind of take a step back to showing congruent triangles. And I can already see what they're doing here. They're going to use corresponding parts of congruent triangles to show that one angle is congruent to the other, namely alternate interior angles 1 and 4 and 2 and 3. And then, as long as alternate interior angles are congruent, then we can prove parallel lines. So it's kind of this process of how do I get from my starting point, how do I move forward with that? And with this one, it's a little easier because some of the pieces are filled in for us. So we do get to ones where we don't have all of this filled in. So RT. So I'm just showing RT is congruent to RT. So I have my third side there. Well, if I can prove that all three sides of one triangle are congruent to all three sides of another triangle, those triangles are congruent. So I can go RTQ. So I went RTQ, and I need to make sure that I'm going in the correct direction. So it's going to be TRS. TRS. And even though the R's are in different positions here, they don't represent the same thing. The R, when I'm talking about RTQ, represents this side, the 1. And when I say TRS, it represents the 2 here. So it doesn't represent the exact same thing. So T and R represent the same angle. 1 and 4 are those alternate interior angles that we're going to prove. Okay, so just be careful how you type that because that will matter. So I want to go down to, usually these are at the bottom, so side, side, side congruence, and they've shortened that to be SSS. So I'm showing that all three sides of one triangle are congruent to all three sides of the other triangle. So now that I know the triangles are congruent, I can use CPCTC. Congruent parts of, corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. So now I can say that angle 1 is congruent to angle 4 because they're corresponding to each other. And it's R and T, right? That's R is 1 and T is 4. And then I can also show, I'll just do this in green, I guess. 2 is congruent to 3, corresponding parts. So I have R for the second triangle and T for the first triangle. So remember, we're using the same letters, but they represent something different because we're talking about different triangles. So I know that can be a little confusing too when we have the same letters, but they represent something slightly different based on the triangle we're talking about. All right, so now I have my angles laid out, and they're going, QR is parallel to something. So QR, this guy here, is going to be parallel. Well, if I'm just kind of using logic, it's going to have to be parallel to this other side here. But I have transversal to parallel, those are alternate interior angles. So that's the reason that I can say that these are parallel to each other. You can go down and find if alternate interior angles are congruent, then the lines are parallel. So make sure you're choosing the right one, because there is one that says if the lines are parallel, then alternate interior angles are congruent. We don't want that one. We have the angles first, and we're proving that the lines are parallel. So we're going to do the same thing for the bottom and the top. So it's going to be RS. And it's still the same reason there. This guy, yep. Alternate interior angles are congruent, then the lines are parallel. So we just proved that the opposite sides were parallel. And that's the basic definition of a parallelogram. As long as the opposite sides are parallel, both pairs of opposite sides are parallel, then it is a parallelogram. And that's the reason we're going to go through and look at definition of a parallelogram, I believe. Definition, I don't see it yet. Ooh, I want to be logged in like that. That's a little too much. Oop, down there. Definition of parallelogram. There we go. It just took a minute to load. All right, so I believe we're going to do a proof. Oh, this one's still a little bit fill in the blank. I think the last one we do doesn't have any more fill in the blank in it. So now we're going to do if opposite angles of a quadrilateral are congruent, then it is a parallelogram. So still, quite a few steps there, but we're going to go through and prove that same idea, but now we have angles instead of sides. So now I have R, S, Q, T, and we are told that Q is congruent to S and R is congruent to T. So opposite angles are congruent. And they've already put this in the given for us. They're also just go ahead and giving us that all four angles add up. If we add all four together, we get 360 degrees, and that's a quadrilateral angle sum property. So now, if we look at what are they doing on this fourth step here, we have Q and R, that didn't change. But now, instead of S, they have a blank, and instead of T, they have a blank. And what they want us to do instead of S, they want us to use substitution. And I can see that because they're telling me to use substitution here. So I'm going to substitute instead of angle S, I'm going to say angle Q. And instead of T, I'm going to go R. And then that way, they still add up to 360. All I did was replace, instead of this S, well, I know S also equals Q, so I replaced it. I substituted it. And with T, it equals R. So why are we doing the substitution? What we're trying to get to is something similar to the idea that we were doing in the last one, but we don't have a transversal to use alternate interior angles. So now, the easiest way to do this with angles is using the consecutive interior angles, or supplementary, or this one right here. Or run one right after the other. If we add one of these, S to T, or T to Q, or Q to R, whatever we add together, they should add up to 180 degrees. We want to prove that really quick. If we can prove that, then we can show that the lines are parallel, because that's also one of the ways to prove parallel lines. So now we're just combining some like terms here. So we have Q and Q. So we have, instead of 2Q, they're just having us write the 2 out front. So it's 2Q, and there's also 2 R's. They still add up to 360 degrees. We haven't done anything with that. We're just simplifying the idea that we have 2 of each angle. And then from step 5 to step 6, we can see all of a sudden there's no more multiplied by 2 anymore, but now we have 180. So what they did is they used multiplication division properties, specifically division properties, and they divided both sides by 2. So that we just have angle Q and angle R equal 180 degrees. So now angle Q and angle R are supplementary angles. Well, if they add up to 180, that's just the definition of supplementary angles. So let's see, we need to find that. Definition of supplementary angles. And because supplementary angles are found here, one right, or consecutive angles, R and Q, add up to 180, this shows that RS is parallel to QT, because that is one of our properties. Let's see, I want QT. And now we have Q plus T. I'll do this guy in pink down here. Add up to 180 degrees. And with this one, let's see, which, they're not using quite the same reason here. This one is, I believe, going to be substitution, because instead of R, we're substituting R for T. So we're going all the way from step 6, we have Q plus R equals 180. And then we're skipping down here, and instead of Q plus R, we're writing Q plus T, because T and R are the same. They equal each other. So we're substituting, again, T for R, so we're going back to T on that one. So now we can say that angle Q and angle T are supplements of each other, which is just the definition of supplementary angles once we prove they add up to 180 degrees. So now that shows that, oops, I don't know why I wrote it that way, that ST and RQ are parallel, and that's if consecutive interior angles are supplementary, then the lines are parallel again. So we're just using that consecutive interior angles are supplementary. So now we just showed opposite sides are parallel. So again, that's, we're trying to get to that definition. And it again told us that, I didn't read that part again, but it told us to use that in the definition, or in the proof, that definition. We were trying to get to that piece. Here we go. All right. Last one here. Okay, so we're going to look at this guy, and we're going to look at it based on the slopes. So this one can be a little bit different because we're filling in a vertice that's missing. We need to figure out where the fourth vertice will be, and we need to remember that they have to be parallel lines. So the slopes have to match here, like this. And I'm going to write these in here, just because it makes it a little easier to picture this, I think, like this. Okay. So with this one, if I'm looking at the slope of this side so that I can match it to the slope of this side, so I can figure out where's this coordinate going to be, I want to figure out rise over run, like this. So how far do I have to drop down here, which is my y's? Remember, it's x, y, x, y. So if I'm going, and there's a comma here, it just kind of came up funny. So for my y's, if I'm going -2 to -5, well, that means I dropped down 3. So I just had to go from 2 to 5. And then 5 to 5, if I'm going from -5 to 5, that means that I'm going +10. So I'm not going -10, I'm going +10 because I'm going to the right. So I actually want to do the same thing going like this, because I want it to be the same exact slope. So I want to go down 3 and right 10. So I started at -7, so -7 plus -3, well, that's going to be -10. And then for my x, I started at -7 and I'm going to add 10, so that's going to be 3, like that. So I'm going to go ahead and type this in, 3 and -10, and we'll go ahead and check. Perfect. All right, so that was section 2. I will see you in section 3.